Hi, I'm Martin Bly, working on system software for Chrome OS. In this video we're going to discuss one of the core goals of Chrome OS, which is speed. That means end-to-end measurements, redesign and tuning, but we're going to start by looking at one specific example, which is boot speed. Our goal is to get the user from pressing the power button to the web as quickly as possible. Let's start by looking at what you have to go through on a traditional operating system to get to email. The user presses the power button and the computer's firmware starts. The firmware searches for components that could be inside the computer and also looks for ones that could be plugged in externally and initializes them one at a time. Then they display a pretty splash screen just in case you forgot who made your laptop. After the firmware finishes, it loads and starts the bootloader. The bootloader loads and starts the kernel. The kernel searches for components again and initializes them again. Then they put up another splash screen just in case you forgot who sold you the operating system. A complex set of services and applications gets started. Now the user gets to log into the operating system. It then fires up all the applications in your start folder. Over the years, these applications have grown very large and cumbersome. Often this includes parts of applications you don't even need yet, just so they look faster when you do go to start them. Start antivirus software to protect yourself against malware. Then the user gets to click on the browser icon. Now you have to log in again to cloud services like Gmail. How does that change with Chrome OS? Our goal is to boot from power on to the web in just a few seconds. We also set a budget of resuming from suspend in under a second. So we set out to do some serious spring cleaning and simplification, starting by measuring and analyzing every millisecond of boot up time. Let's look at some of the things we're changing. This is an appliance-style device, so we already know what's on the machine. We don't have to go searching for it. We're not going to issue a command and then sleep for 20 seconds to wait and see if you have a floppy disk drive connected. Initializing hardware is slow. By moving it from the firmware to the kernel, we can start multiple devices in parallel. For example, we can keep streaming data from the disk while we wait for the video display to start. Let's get rid of those splash screens. They just waste time. We don't need a bootloader. We can just jump straight to the kernel. We're simplifying complex layers of legacy software. The browser is the focal point of the system now. This is a native web device, so you don't have to log in twice either. We're also using solid-state storage devices, like in your camera or your phone, not hard disk drives, a technology invented over 50 years ago. That means there's no moving parts. We don't have to wait for a mechanical head arm to move from side to side before we can get your data. When you close the lid, the netbook will go to sleep. When you open it, it'll wake up in under a second. Simple. So if you're a systems engineer, take a look through this and let us know, what else can we cut out? Can we get to 4 seconds? 3? Go to chromium.org and learn more.